Okay, so we've got a patrol point, which is an F vector, and we've added a make edit widget meta specifier so that we have an edit widget and we can use that widget to move this vector location in the world. But we saw that this vector is local to the enemy, so we needed to use a transform function to transform it to world space. And we used the function from Kismet Math Library, transform location, using our enemy's transform, and we transformed our patrol point vector and stored that in a local F vector here in begin play. We then used draw debug sphere to draw this transformed vector to prove to ourselves that we have the correct world location for the vector. We're now ready to start using our behavior tree in order to move the enemy character to our patrol point. So let's first go into our Blackboard so we can add a key. Remember, the Blackboard acts like the brain for AI in Unreal Engine. This is where we're going to have values that the behavior tree will use. So we're going to add a new key. Now click New Key here, and the drop-down will pop open asking us what type we would like to use for our key. Let's select Vector, and let's call this Vector Key Patrol Point. Now we have a key in our Blackboard. Now we can set the value of this key from our enemy class. So let's go back into enemy.cpp, and we're here in begin play. Now we've just created this local world patrol point. We can go ahead and make this const since we're not going to change it in begin play. Let's go ahead and use this vector to set the value of that key. In order to do so, we need to access our AI controller in order to get the Blackboard component on that enemy controller. So since we're going to want to access our enemy controller, why don't we create a variable on enemy.h for this controller? I'm going to forward declare this here in the private section, and this will be of type enemy controller. This is a pointer. I'm going to call this enemy controller. Now in begin play, we want to get that controller. So let's do this here just above our local F vector world patrol point. We're going to say enemy controller equals, and we're going to cast to a enemy controller. And what we're going to cast is the result from get controller. So we're going to call get controller. This will return us a controller, and we're going to cast that to a enemy controller, which means we need to include the enemy controller header. So we're going to include that up here at the top. I'm going to say include enemy controller.h. So now at this point, we should have our enemy controller. So let's add a comment here and say get the AI controller. Now just after our call to draw debug sphere, we can use our enemy controller and set the value of the key that we created called patrol point. So let's get our enemy controller, and remember the enemy controller class has a public get Blackboard component function. We're going to call that to get the Blackboard component. And from the Blackboard component, we can call a function called set value as vector. This is how we set the value of one of the keys on the Blackboard. Now get Blackboard component returns a uBlackboard component, which means we need to include that header. We can go to enemy controller and get our include for the Blackboard component header, and we can paste that here in enemy.cpp. So let's get that and paste it in right there. Now from the Blackboard component, we're calling set value as vector. This requires an F name for the key name, and we're going to pass this in using the text macro. And this is called patrol point. Now the next argument needs to be the value we want to set this vector to. And we're going to use world patrol point, since this is the value of our patrol point vector transformed to world space. So let's use that. So we're getting our enemy controller and calling get Blackboard component. This returns the Blackboard component, and we're using that to call set value as vector to set our key called control point on the Blackboard to the value of world patrol point. Now, before we do this, we should check to make sure enemy controller is not null. So we're going to place this in an if enemy controller check. All right, so now we're setting the value of patrol point from here in C++. Let's go ahead and compile this code. Now, while that's compiling, we're going to jump back into the editor. And in the editor, let's open our behavior tree. Now, here is our root node. And we can use our patrol point key here in the behavior tree. If you hover on the bottom bar of the root node, click and drag out, we can place a new node in the behavior tree. Now the options we have here are selector, sequence, and simple parallel. Choose the sequence and we'll create a sequence node. Now remember from our slide, the sequence node can have child nodes and it executes each child node from left to right and continues to do so until one of them fails or all of them succeed. We're going to add a simple task to our sequence node. So on the bottom bar of the sequence node, click and drag out, and here we have some options. Expand the drop-down next to tasks, and there are a handful of pre-made behavior tree tasks to select from. We're going to use a move to task. Now, the move to task is a simple behavior tree task that causes our AI character to move to something. Here in the details panel, we have some settings for the move to task. Now, under Blackboard, we have Blackboard key. If you click the drop-down, we can select one of our keys. Select patrol point, and now our move to is using the Blackboard key patrol point. This is the location that our character will move to as soon as this task is executed. Now notice in the node section in the details panel, we have an acceptable radius, and it's set to 5. This determines how close the character must get to the target location before this task node is considered completed and thus successful. Once the enemy reaches this point within the acceptable radius, the move to node will return success back up to the sequence node. At this point, the sequence will have considered all of its children to have succeeded, and the sequence node will return success back up to the root, at which point the root will start the tree all over again. Now, if the character is already at the move to location, then move to will simply return success again, and the sequence will return success to the root again. So the character will simply stay at that move to location. Go ahead and click save. Okay, so we're ready to test this out. And one of the last things we need to set is our enemy controller on the enemy. We need to make sure our enemy is using this controller. So let's go to our enemies folder, open up enemy BP, and we'll go ahead and with enemy BP self selected, go ahead and search for controller, and you'll see that we have an AI controller class, and we can set this here. We're going to click the drop down and select enemy controller BP, compile, and save. Now, since this is set for our AI controller class, now whenever we call getController here in enemy.cpp, right here, when we cast to a enemy controller, we will actually get an a enemy controller. So that is great. Now we're almost ready to test this. The last thing we need is a navigation mesh. Remember from the slide, in order for our AI character to move, we need a navigation mesh in the world. So here in the search classes search bar under place actors, we can search for nav, and we'll see that we have nav mesh bounds volume. Go ahead and drag that in, and we're going to scale this up. So scale it up and scale it out in the X and Y directions. Now we can see the nav mesh bounds volume if we hit the P key on the keyboard. And now you will see green wherever the nav mesh bounds volume exists in the world. Now, if we go up to this wall here, for example, you'll see where the nav mesh bounds volume ends. This is a spot where the AI character cannot move. So things like the barrel here will place a hole in the nav mesh bounds volume. I'm going to hit P just to hide the volume so we can see what we're doing. Now, I'm going to select the enemy and take our patrol point and move it to a different location. That way we can select where our AI character is going to move. So we have our nav mesh bounds volume, we have our behavior tree, we have our enemy controller BP, and we're setting that here in the enemy class for the AI controller class. We're setting the value of the patrol point key in our blackboard here in the enemy begin play, and we're ready to start the behavior tree so the enemy can move to this patrol point. Now, in order to start the behavior tree, we're going to take the enemy controller and we're going to call a function called run behavior tree. And run behavior tree takes a behavior tree, and we have a behavior tree stored on our behavior tree variable, so we're going to pass that in. Now, as soon as this function gets run, our behavior tree will start to execute the nodes starting at the root node. So let's compile this. And as soon as that behavior tree starts, our root node will be kicked off. We'll enter the sequence node, which will begin to execute its children. Now, there's only a single child node, so we're only going to do this move to task. And as soon as we start the move to task, we should start to see our enemy move to the patrol point here. Now, I'm placing this barrel right in between the enemy and the patrol point. I want to see what happens when the enemy has an obstacle between itself and its target location. What will happen? Will the enemy just get stuck at the barrel, or is it smart enough to move around? Let's find out. So we're all compiled, and I'm going to go ahead and hit play, and there goes the enemy. Notice the enemy went around the barrel. That's because this move to task is a little bit more intelligent than simply going to a location. You see, the collision of the barrel is going to block the enemy, but the enemy is smart enough to go around obstacles. And we can see proof of this if we copy the barrel and make multiple barrels. Say we have a line of barrels, and if we block the way this way, then the enemy will be forced to go around. I'm going to hit the P key, and you'll see that the nav mesh does not allow for movement past these barrels. The enemy will have to go around. So let's see how this works. Let's go ahead and hit play. And look at that. The enemy went all the way to the end of this line of barrels and went around to get to that point. Now, we can move the patrol point to literally anywhere as long as it's in the nav mesh. So if I move it, say, somewhere out here and hit play, then there goes the enemy, and it's going to keep going until it gets to that patrol point. So that's the point at which our move to task completes, and if the enemy reaches the acceptable radius within 5 units away from the patrol point, then that task will return a success. So that's going to conclude this video. In the next video, we're going to take care of actual running animations for Grux, because Grux is just sliding along the ground, and that doesn't look quite right. We're going to need to fix that in the animation blueprint, so we'll do that in the next video. I'll see you then.